Section 3.2, we're going to look at parallel lines and transversals. In the last lesson, we looked at just two lines being cut by a transversal. So in this first slide, I'd like you to try to identify the types of angles for questions 1, 2, and 3. And if you did your work correctly, you would see that angle 5 and 7 are corresponding, 3 and 6 alternate interior, and 1 and 8 alternate exterior. Notice this picture is much more complicated. You actually have the two yellow lines being cut by the two green transversals. And you also have, I re-highlighted, the orange lines are being cut by two pink transversals. So you're going to have multiple transversals at times and multiple lines. And so it's important to distinguish and maybe highlight which are the lines and which are the transversals. So in this lesson, we are going to find missing angles using theorems formed by parallel lines cut by transversals. So imagine if you use your protractor to draw a pair of parallel lines and you draw a transversal that cuts the parallel lines, and then you go ahead and measure all of the 8 angles formed by the transversal and the parallel lines. What do you think might be true about the relationships between the angles? What does it look like is happening? So think about that for a minute and see if you can make any conjectures based on the drawing I have on it here. Well, you might be able to think about this a little bit, and you obviously could probably see that angle 2 and angle 4 are a linear pair, and that's a relationship we already learned. And there are lots of linear pairs in there. We also learned earlier, so don't forget, is that we have vertical angles. So angle 1 and angle 4 are vertical angles. But did you think about any of the other angle pairs that we learned about, like alternate interior, alternate exterior, corresponding, etc.? Well, there are 4 theorems that apply to lines that are parallel and cut by a transversal. So that's very important, is the lines have to be parallel. And it turns out that many of them are actually congruent. And we'll actually prove some of these things as time goes on, but I wanted you to see if you could maybe process through and make a conjecture. So if you do have these two parallel lines, and it's cut by this transversal right here, we know that the lines are parallel because of that arrow marking. So the alternate interior angles theorem says that if you have parallel lines cut by a transversal, then the alternate interior angles are congruent. So what that means is angle 4 and angle 5 will be congruent. So angle 4 is congruent to angle 5. And also angle 3 is congruent to angle 6. So what that also means, again, remember that when we have congruent angles, we know that then the measure of angle 3 is going to equal the measure of angle 6. And the measure of angle 4 is going to equal the measure of angle 5. And again, if you have parallel lines cut by this transversal, the alternate exterior angles theorem says that then alternate exterior angles are congruent. So that means that angle 1 is congruent to angle 8, and our other pair is angle 2 is congruent to angle 7. And again, that means that the measures will be the same. So what about the other two angle pairs we learned about? Well, turns out that the corresponding angles will also be congruent. So the corresponding angles postulate, and remember, postulates don't have to be proven. They're accepted without proof. So later on, when we do proofs, we're going to always go back to this corresponding angles postulate to prove the consecutive interior angles theorem or alternate interior angles theorem. But if you do have these two parallel lines, again, marked that way, cut by this transversal right here, then the corresponding angles are congruent. So that means, again, your corresponding is same position. That means that angle 2 and angle 6. So angle 2 will be congruent to angle 6. Angle 1 will be congruent to angle 5. Angle 3 will be congruent to angle 7. And angle 4 will be congruent to angle 8. So that means when we find all the missing angles, we can now use those theorems and the postulate. So again, if you're looking at these parallel lines cut by this transversal right here, we know that we could find angle 2 right here using vertical angles being congruent. So that is going to be 55 degrees. We also know that we could find angle 1 right here because the 55 degree angle and angle 1 have making a linear pair. So that means 180 minus 55 would be 125 degrees. So angle 1 is 125 degrees, the measure of it. And angle 2, the measure of angle 2 is equal to 55 that we found. And the measure of angle 3, we can either use this linear pair again, or we can use 1 and 3 are vertical angles, so that will also be 125. But what do we do down here? Well, we have angle 4 makes a linear pair, so angle 4 also has to be 90 degrees. And here is where we get to using some of those theorems. So remember that angle 2 and angle 5 over here are alternating across the transversal, and on the interior, alternate interior angles are congruent, so that makes this 55 degrees. So the measure of angle 5 equals 55 degrees. And now we can use another pair of alternate interior if we want, angle 3 and angle 6. But once you get one of the angles in this bottom cluster of 4, then you can use vertical angles and linear pairs, which is usually a lot easier. So now we again have the angle 6 is 125 degrees, and angle 7 is 125 degrees, and angle 8 equals 55 degrees. So it turns out in this picture there are 8 angles, well 9 if we count 4, and we have only 2 measures. Kind of interesting. So we're going to get more challenging questions as we go through this. And so let's take a look at this one here. We have a 77 degree angle right here. So the angle 2 is going to be 77. We have these 3 angles right here they are all together making a linear pair. So when we add 77 and 37, we get 114. So this has to be 66 degrees. Now we have a vertical angle right here with this number 3 and number 12. So this is also 66 degrees. And now again, we have another vertical angle. So this is 37 degrees. So now we need to go down to these other two pictures. So again, if we highlight this parallel line with this parallel line, I probably could have highlighted that at the beginning. Then we have transversal right here. Here's one transversal that we can use. And so let's go with that one first. So now what we have is, if we're going to look at an alternate interior angle, I tend to like to use that. This angle right here and this angle right here are alternate interior angles. So that makes angle 577 degrees. Now we could use linear pair. If you're looking at the other pair of alternate interior angles right here, remember that this transversal goes all the way up here. So if you're going to add those together, that is going to give you 66 plus 37 is what angle 4 equals. So that's why it's good to highlight, because sometimes you might have gone 37. You thought angle 4 was just equal to this 37, but you have to add both of those together, which gives you 103 degrees. And again, once you get one of the angles in the cluster, I would just use vertical angles and linear pairs to fill in the rest. So now let's examine those parallel lines with this second transversal right here. So again, I tend to like to try to use alternate interior angles. So here's my transversal, and here is my alternate interior angle with angle 8. Sometimes you might want to use alternate exterior or corresponding. You could use any of those options. But so that makes angle 8 66 degrees. And now you could just continue to use vertical angles and linear pairs to get the rest. And hopefully we're going to challenge you with some more problems where you have multiple parallel lines. Those are marked with 2 tick marks. And then you have a parallel lines right here and here. So you have another pair of parallel lines. And so you have to sort of pay attention to all of the markings. And then you have multiple transversals as well. Here's one of them. We're going to skip that one for now, and we're going to go on to solving some with algebra. So now you're going to use the same ideas, but you are going to solve. So what angles, again, what I'm given here is parallel lines, and here is my transversal. And so what I'm given here is this pair of angles right here are consecutive interior. So those are consecutive interior angles, and those are the ones that are congruent. So that means that, or those are the ones that are supplementary. You know, I think I forgot to actually do that one. I'm gonna have to go back. So 13x plus 23x is equal to 180 degrees. I just realized when I skipped down to corresponding, because those are the ones that were congruent, we never did this piece right here. Consecutive interior angles, okay, are the only ones that are not congruent to each other, but they are called supplementary. So consecutive interior angles, if you have parallel lines cut by a transversal, then consecutive interior angles are supplementary. So what that means is that angle 3, the measure of angle 3, plus the measure of angle 5 is equal to 180 degrees. And likewise, the measure of angle 4 plus the measure of angle 6 is 180 degrees. Sorry about that. I apologize for not doing that in order. But now what that does is gives us an opportunity to solve this. So now we just add the x's together, solve for x, and we get x equals 5. But that just helps us get this particular angle. So now when we take 13 times 5, that gives us 65 degrees. So now being supplementary, take 180 minus 65, that gives us 115. That's not very neat right there. So that gives us 115 degrees for that angle. So now, again, can go ahead and use all of the other angles like vertical angles, 115, and linear pairs, which makes this one, or again, I could use corresponding and get 65 degrees here, and vertical angles, and I already have all of these other ones, then I can just fill in. Okay, so let's go on and let's try to set up and solve some more examples here. So now we're solving for all of these angles. And again, look at what you have. Look at you have your parallel lines cut by this transversal. And what angle pair you're given here, right there, is alternate exterior angles. And alternate exterior angles are congruent, so we set 4x minus 45 equal to 2x plus 15. That gives us, when we get all the x's on one side, numbers on the other, solve, we get x equals 30. So now we can plug 30 in. 4 times 30 minus 45 gives us 75 degrees. And that makes angle 2 75 degrees. And now we can use linear pair to get the rest of them. So that makes 105 and 105. And again, we already know that we have alternate exterior angles are congruent. So that makes this angle down here the same. And it makes 105 and number 6. 1 and 6 are alternate exterior, so 105 again. And again, just use either any of the 4 theorems for parallel lines or vertical angles and linear pairs. All right, so now our picture again gets a little more complicated, but here's our parallel lines. And we actually have 2 transversals. Here's one. And here's another one. So even though these lines, don't always continue, okay, we can draw them that way because a segment is always part of a line. So now, what do we have? Well, we want to solve for these angles. And what we have here is we actually have these 2 angles are also consecutive interior angles. And remember, those are the ones that are not congruent, but they are supplementary. So then you would add them together, 16y plus 14y equals 180. And when we solve, we get 30y equals 180, so y equals 6. So now we can take 14 times 6 and get 84 for this. And we can take 16 times 6 and get 96. Or we could just subtract from 180 since they're supplementary. And these are also consecutive interior angles right here. So we can do the same for that. 9x plus 6x equals 180. Or 15x equals 180, so x equals 12. Substitute your 12 back in here, and this gives you 72 degrees and 108. See if you can set up and solve this next one. So in this problem, you actually have 3 different transversals. You're not necessarily going to have to use them all, but what I noticed right away is that with this transversal right here, this angle right here, and these angles together would have to be 90 degrees, because that 90-degree angle plus the 11x minus 5 plus the 8x has to equal 180, because those are consecutive interior again. Now, really, we could cut this problem down by just setting 11x minus 5 plus 8x equal to 180, because that has to be 90 if those two are supplementary. I just set it up so that we would use consecutive interior angles, but then when I subtract from 90 from each side, that would give me, and add the x's together, that gives me 19x minus 5 equals 90. So now I have 19x is equal to 95, and if I take 95 divided by 19, that gives me 5. So x equals 5. So this angle we know is 90. We already have that marked. I guess we could actually write it in. But then this angle right here, just this part of it right there, that little angle right there, is going to be 55 minus 5, or this angle is 50 degrees. And then this is 8 times 5, or 40 degrees. So this angle right in here, that part of it, is 40 degrees. Now we need to know, we can actually use alternate interior angles here because of this green transversal right here. This green transversal, we have this angle right here and this angle right here are alternate interior angles. And so this part of the angle will be 50 degrees. But then you also have this angle right here and this angle right here are also alternate interior angles, so that is 40 degrees. And now if we look at finding this angle right here, so now we need to find this angle right here. Well, again, you see what we have for that. We have this transversal right here with those parallel lines. And so that purple angle right there and this angle right here, these two combined, those have to be, those are also consecutive interior angles. So that purple angle, we'll call it X for right now, just so you can see it. So X plus 40 plus 50 has to equal 180. So this is 90. And so that makes that 90 degrees. That does not seem right. So let me go back and look at my alternate interior angle. So I have parallel lines cut by that transversal. That should be right. And that should also be right unless I substituted something in wrong. I'll go back and look at that a little bit more and make sure I correct it on the key. But that, let's move on to the next example here. So now we have, let's just at least set these up a little bit. So we have, these are parallel lines, all three of them. And you have one transversal right here. And you have another transversal right here. And so what you have here is you have this angle and this angle are consecutive. So you have, those are consecutive interior angles. So 98 plus 3x plus y equals 180. And you have this angle and this angle. So you have 3x minus y plus 110 equals 180. Now, because these are all in the same problem, we actually are going to have to use a system of equations to solve. So I'm going to subtract 110 from each side, and that's going to give me 3x minus y equals 70. And I'm going to subtract 98 from 180 on the top problem, and that is going to give me on this top equation 3x plus y equals 82. And now I'm going to take this and set up a system of equations, and I can actually use elimination here. So 3x plus y equals 82, 3x minus y equals 70. Add the two equations together, the y's eliminate, and I get 6x is equal to 152. So now 152 divided by 6 gives me decimal 25.3. Just checking my math here and make sure I didn't do a typo. I didn't expect to get a decimal, but I certainly can. And it looks like my math is right, so 25.3 repeating, or as a fraction, that gives me the fraction 76 thirds. So x is equal to 76 thirds, or approximately 25.3 repeating. Well, that's the exact answer actually with the repeating piece. And so now how do we find y? Well, remember from this, you just substitute the value of x into one of the equations for x. I'll just go ahead and put it in this one. So 3 times 76 thirds plus y equals 82. So I'm going to take 76 thirds times 3, and that gives me, obviously those cancel out, gives me 76 plus y equals 82. So now I subtract 76 from 82 and get 6. So y equals 6. So that one's a little bit more involved, and I thought it would be good for